What's up? Zoran, you are the only one here, I think. I don't know, my control panel says one viewer. I'm watching Action Retro talking about MorphOS. MorphOS. Ah, the Amiga wannabe operating system that works on PowerPCs, including the older Macintosh computers. The one that has a trial period of like I was going to say a month, but I think it's a half an hour actually. Yes. 8-bit banger. Welcome in. At some point I was thinking about getting not MorphOS, but hardware for it. So one of the older Macintosh computers, Mac Mini, is it the name? The desktop cube, small one. But they are kind of expensive. I mean, not that expensive, but they are kind of useless as a devices for doing anything anything productive nowadays. More like a toy, right? So I didn't get it. I didn't get it. It was not a problem for me to shell out like 1,000 euros for Amiga. Because that's the actual computer. It did cost me less, but I kind of added up more stuff to it. It adds up to 1,000. That was not a big deal because I really wanted it. And no, you can't do anything truly productive nowadays on it. But from the perspective of a nostalgia, it's very good value. But an old Mac, it's just a toy. You can run MorphOS in QEMU emulator on Linux. It works just the same. You will run it once or twice and then delete it. It's not really worth trouble, in my opinion. That's mine, right? The reason why I like actual hardware that I used to love is purely a nostalgia factor, right? Growing up with those systems. And I did not grow up with a Mac, so I don't give a shit. There was another OS for PowerPC, Phoenix or something like that. I don't know. I was never into PowerPCs whatsoever. When Amiga was supposed to transition to PowerPC processors, that's when Commodore died. So nothing really happened. There are some of the Blizzard branded PowerPC accelerator cards for my Amiga. So I can run PowerPC based Amiga OS version 4. I just don't, how do I put it? All of the true Amiga fans are into the old original operating system. So the Amiga OS version 4 is nothing. Nobody really cares. There are some developers who still work on it, like homebrew stuff, trying to port Chromium web browser on it and stuff like that. I don't have any bread in that. Understood? I wasn't really, explaining anything. It's just that providing some of my opinions, because I already went through some of these things that you're talking about. Simply from a perspective of, okay, now I have Amiga 1200 and maybe I want to collect some more, and maybe branch out a little bit into other operating systems that are inspired by Amiga operating system. And it is a bit of a rabbit hole, but only if you really care, which is that I don't actually, because the true Amiga operating system is still being developed. So just my OBS here, Hyperion, Amiga OS. New update 3 for Amiga OS 3.2 available for download, April 2, 2025. Some of the highlights in update 3, reaction classes received numerous updates. Text editor now allows users to define a custom menu. 12 kilobytes of cheap RAM no longer reserved. A new kickstart ROM. Some other fixes for this doctor had a toolbox. Yeah. All I wanted to say is that they are still developing it. Not the Commodore, because Commodore is dead, but the ones who hold the intellect. How do you put it? The license holders, or whatever you call them, right? They are still working on this operating system, so it's cool. It's cool. Heretic 2, you remember that? Not sure what Gorky is. Gorky 17. It's a game. Week. Yeah, cool stuff. How many people do we have? We had 7 people joined just like a moment ago. Not anymore. Well, this is on the screen, and let me see. What was my what was the IP of my demo operating system? I keep forgetting. It was $2,206. Yeah, it was 206. Yeah. Got that's issue. I kind of upgraded it to Debian Sid, but I must be honest. I don't understand Debian Sid. People keep branding Debian Sid as Debian rolling distribution. And also on the Debian website, it says that it is a rolling distribution. So if we go to the basic explanation of what rolling means, basically it means that you keep getting updates indefinitely and it never stops. So from that basic definition, SID is a rolling distribution. But I try to argue that it's not a rolling distribution, not because it's not really rolling. It is rolling. You are getting infinite updates. But when people want to choose a rolling distribution, one of the most popular choices is Arch Linux. So Arch Linux being one of the representatives of what a rolling distribution truly means for the end user is that you keep getting updates. Like the cadence of updates is very steady. Correct? From Arch Linux. Princess Ashley 99, welcome back. So from Arch Linux perspective, you get steady updates all of the time. Whatever comes out, developers push it to you in a pretty short period, and you get it. If the developer is a bit late, then other people flag the package as being obsolete, and you get it very soon. Sid means still in development, and it will drop out of development to stable, I think. Yeah, that's what I was trying to discuss. So Debian is all about stable, and stable comes out roughly once in every 2 years. Usually it comes out in summer. So roughly half a year before the next release is due, they have a testing version of Debian being frozen, like in stages, but gradually it gets more and more frozen until it becomes stable. And from testing, we get stable, and testing comes from unstable. So I don't know, it's kind of weird because I mean the procedure to get stable is not weird. What is weird for me is Debian Sid, because if you want to use Sid as a true rolling distribution, you actually cannot. You can't, because I am on Sid now, and if I do sudo apt update, sudo apt update. Okay, let's update everything. Just a question, are the YouTube comments displayed on Twitch? No. The comments that you see above my head, this is the live stream. So so Princess Ashley is on Twitch, and whatever she types in Twitch chat, only Twitch users will be able to see it in Twitch chat, but also it will be shown on the video stream. Same goes for YouTube. What you guys type on YouTube, only other people on YouTube can see, but it also replicates on the video feed. So one of the reasons for the video feed is because you two can talk to each other like that. You know, Princess Ashley can see what you're typing on YouTube by looking at the video, and you can see what she's typing by looking at the video. There is another way that I can do this. I can tell my bot to type into YouTube chat everything that someone else types on Twitch chat, but that kind of looks stupid. I have seen it on other streamers, and it looks stupid. It looks like on the chat you see the bot name, and then you see bot saying a name of the person on Twitch and then what the person said. So I don't know, it's kind of stupid. It is displayed on the live stream, yeah. Sudo apt full upgrade. So as you can see, there is a kernel upgrade or something. Let's upgrade everything. Another reason why I have the chat on the video feed is because I want it to be recorded, because all of the people who watch these live streams as a video on demand afterwards, there is only one way for them to follow the chat, and chat is very important for these lessons. There is only one way for them to follow the chat, and that is by logging into YouTube and opening the chat interface on the side. However, these video on demands show up also on my Twitch history, although they get deleted fairly soon because Twitch doesn't allow me to save a video on demand. Also on my PeerTube, there people cannot follow the chat unless it's in the video feed. And also on my Odyssey, there people also cannot follow my YouTube chat unless it's burned into the video feed. And if I decide to post it on Rumble or something like that, same thing goes, right? So you have to burn the chat into the video feed, otherwise it gets lost. Sudo reboot. There we go. My Sid is fully up to date now. Let's boot it up. I want to show you something. Let's see if it booted up. Not yet. Now it did. Okay. So uname-a Zoran, as you can see, my Debian Sid, which is supposed to be a rolling distribution, is using a kernel version from December. Correct? 6.12 is kernel from December. And the reason why Sid is not getting a newer version of the kernel, because they just don't care about Sid users at this moment. At this moment, all of the Debian developers are focused on pushing Debian stable out of the gate. So Sid and testing, not important. I mean, it's not that they are not working on Sid at all. They are. As you can see, I did update something, but usually you get much more updates. Basically, once the Debian 13 gets out of the gate, once it gets released, then the floodgates will open and Sid will get a ton of new updates because all of the focus will shift towards starting the Debian 14 development, and Debian 14 development basically starts with Sid. So it's kind of odd. It's not like Sid is frozen. Alexei tried to explain it to me, but I still don't get it. I still don't get it. I mean, Sid is a playground for developers, for Debian developers. I don't see any other purpose for these versions of Debian than just being for developers, right? So you can't rely on Sid to give you the latest kernel, because they just don't have time to be focused on Sid at the moment. Who has joined. I think we have spent enough time on Debian, so let's do the easy lesson. Alexei is trolling me again, saying that 6.12 is not a December release, but actually May 22. Yes, I know what you're saying, and you know what I'm saying. I'm just trying to figure out who from regular users would want to use Sid as their daily driver. I'm not saying that Sid is not usable. It's just that either you want stable and you get it every 2 years, or you want a real rolling distribution which is not burdened by releasing a stable one occasionally. So why would anyone use Sid? I don't know. I cannot recommend Sid to literally anyone except to Debian developers who are already using it. That's what I'm trying to get to. Who is Sid for other than Debian developers? That part I don't understand. Also, Experimental is not a distribution because it has a large official repo. But I'm trying to understand, if you are using a rolling distribution, then you want latest packages, I suppose, but you're not really getting those at the moment. You will get them in 2 months or 3. Zoran says I would only use stable versions. No, I'm not arguing what you would use. There are plenty of people who love rolling distributions. It's a legit fine thing. I use a rolling distribution as well. I don't understand you on Kali. That's a completely different story. For me, Kali goes here. This is where Kali needs to be installed and nowhere else. Kali installs on USB stick and you boot your laptop from a USB stick when you want to hack something. And when you're done hacking, then you unplug the stick and go back to a normal operating system. I never understood literally anyone who installs Kali permanently on their computer. It's just weird. But that's another topic. I was trying to figure out who would install Sid. You have Kali in VMs. Yeah, okay. You can put hamburger in your VMs if you want. I'm just saying it's weird. Alexis says, if I am using rolling, I want versions which are new enough for a use case. One can claim why use Arch if you want. Oh, my message ran away. Why use Arch if you want latest software? Then use Fedora Rawhide. Well, Fedora Rawhide is, I would argue, not for users. That one is for true beta testers who want to contribute into software development by truly beta testing for the entire Linux community. Ahmed, welcome in. Lots of silence. Guys, we can talk more about Sid. I'm still not done with that topic, and apologies in advance. Marco, welcome in. Create partitions and file systems. Manage master boot record and GPT. Let's do the introduction. On any operating system, a disk needs to be partitioned before it can be used. A partition is a logical subset of the physical disk, and I'm just going to read that one last message and then we go on. Beta testers are users, developers are users. They only differ in use cases. Not everyone needs bleeding edge, hence existence of Manjaro, OpenSUSE Tumbleweed, and OpenMandriva Cooker. Are you sure you meant Cooker? Cooker is more similar to Rawhide and Debian Experimental. Use whatever you want. Yeah. That was never a question. I was just trying to fit Debian Sid into its place. Like, who is it for? That's all. I wasn't arguing that people should or should not use Debian Sid. Forgot how their branch is called. Yeah, OpenMandriva Cooker is for cooking the next. Cooker is a distribution, a rolling distribution of Mandriva in which developers put something new every day. Like they keep putting stuff into it all of the time, and you can get updates all of the time. The normal rolling one, they call Open Mandriva. I got stuck in my brain. It's testing branch. Yeah, you can call it testing. Mandriva. I forgot. Rome. Rome is the normal one that they call rolling. That's the one that gets updated like once per month. I'm not 100% sure about the cadence, but when I used it, it felt like updates drop once per month, and in between, just some of the fixes that they deem to be very important. And this one is more like Debian stable. Debian 13 works fine, no issues. Of course it works fine, no issues. Even Debian Sid works fine, no issues. The one that they call unstable. It was never really a question that it doesn't work. Has anyone ever heard of Crux Linux? I have heard, but forgot about it. I actually like how OpenMandriva drops their updates, simply because I don't know. For me it felt better to get updates once per month, and only if something is really important it would get updated in between. But generally, the OpenMandriva Rome feels like a stable distribution, which gets a new version once per month. That's a bit odd as a description, and most certainly not an official one. It's just a description that I felt, but that feels fine to me. That feels fine to me. Mavado, welcome in. Have anyone heard about Evil Gnix? Evil Gnix? I don't know. I didn't. If I start listing these distributions right now, we are not getting anywhere with this stream. Okay, so everyone in the chat on both of the live streams, are you ready to start with the lesson? Let's do that. Okay, let's do the lesson. It is supposed to be easy, like the difficulty level 2. So we can just run over it as fast as we can, but with understanding. Alexis says, I just think your stance about Sid being for developers and not users doesn't make sense. Arch is also not for users in a general sense, only for really techie ones who are not far from developers themselves. I can agree with that. But let's continue on that after we kill the lesson. Let's kill it. A partition is a logical subset of the physical disk, and information about partitions are stored in a partition table. For everyone who wasn't watching us from the beginning, there was at least one lesson in the beginning of this year on this same channel, on this same series that dealt with partitions. So if you skipped that one, maybe a good idea to go back and watch that one at your convenience. There is a video on demand. So there is that. This table includes information about the first and last sectors of the partition and its type, and further details on each partition. Usually, each partition is seen by an operating system as a separate disk, even if they all reside in the same physical media. On Windows systems, they are assigned letters like a C colon. Historically, this is the main disk, then D colon, and so on. Coffee Stream bot? Did I enable Coffee Stream bot? When did I do that? I'm kind of confused. I really don't remember when did I do that. But okay. Okay, I have two bots. On Linux, each partition is assigned to a directory under /dev, like dev sda1 or dev sda2. In this lesson, you will learn how to create, delete, restore, and resize partitions using the three most common utilities: Fdisk, Gdisk, and parted. They probably wanted to say file. On Linux, each partition is assigned to a directory. Yeah, I didn't even hear myself when I said it. But yeah, you're right. It's a file under this directory. Where were we? Common utilities. Okay. How to create a file system on them, and how to create and set up a swap partition or a swap file to be used as a virtual memory. For historical reasons, though, this lesson we will refer to storage media as disks, even though modern storage systems like SSDs and flash storage do not contain any disks at all. I think this is fair. Most people call these storage drives as disks nowadays, no matter what the technology of the storage is. So that's good. Understanding MBR and GPT. There are two main ways of storing partition information on hard disk. The first one is MBR, Master Boot Record, and the second one is GPT, GUID Partition Table. MBR, this is a remnant from the early days of MS-DOS, more specifically PC-DOS version 2 from 1983. And for decades was the standard partitioning scheme on PCs, and you can still use it. The partition table is stored on the first sector of a disk called the boot sector, along with a bootloader, which on Linux system is usually grub bootloader nowadays. Stefan Maruda, welcome in. But MBR has a series of limitations that hinder its use on modern systems, like the inability to address disks of more than 2 terabytes in size, and the limit of only 4 primary partitions per disk. GUID, a partition system that addresses many of the limitations of MBR. There is no practical limit on disk size, and the maximum number of partitions are limited only by the operating system itself. It is more commonly found on modern machines that use UEFI instead of the old PC BIOS. During system administration tasks, it is highly possible that you will find both schemes in use. So it is important to know how to use these tools associated with each one to create, delete, or modify partitions. Managing MBR partitions with Fdisk. The standard utility for managing MBR partitions on Linux is Fdisk. This is an interactive menu-driven utility. Menu-driven utility. I suppose you can say that is a menu-driven utility. To use it, type fdisk followed by the device name corresponding to the disk you want to edit. For example, the command fdisk dev sda. So let's go ahead and start dealing with fdisk immediately. But first, I'm going to add a new hard drive so we can play around with it. Let's see what hard drives do we have. ls blk. Let's actually become root. Okay, so we have a VDA as our disk. Actually, I got a bit confused. Why is it VDA? But fine. I know it's a virtual machine, but give me just a second. lpig demo. Let me add a new hard drive here. Virtual disk 1. Add hardware, storage 20 gigabytes is fine. Disk device virtual. I could add it as SCSI or SATA. Then it will probably appear as SDA. Advanced options doesn't matter. Okay. There we go. Yeah, this is the type of the hard drive. I have added a new hard drive, which now appears as SDA, and it is 20 gigabytes large. I'm just minimizing my windows that are in my way. Thank you very much. Let's go back. So they wanted us to use fdisk on dev SDA. Let's do exactly that. Can I do it like this? Looks like I can. Okie dokie. Fdisk dev SDA would edit the partition table of the first SATA connected device, SDA, on the system. Keep in mind that you need to specify the device corresponding to the physical disk, not one of its partition like dev SDA 1. So 1 is the number of the partition. I wanted to use a different phrase, but I got lost. All disk-related operations in this lesson need to be done as the user root or with root privileges using sudo. When invoked, fdisk will show a greeting, then a warning, and it will wait for you for your commands. Welcome to fdisk. The warning is important. You can create, edit, or delete partitions at will, but nothing will be written to disk unless you use the write command. So you can practice without risk of losing data as long as you stay clear of the W key. To exit Fdisk without saving changes, use the Q command. That being said, you should never practice on any important disk as there are always risks. Use a spare external disk or a USB flash drive instead. That's why I added a new disk so we don't accidentally overwrite our system disk and then I need to reinstall the operating system. But it may be a good idea to do a snapshot of the system before I proceed. LPIC demo. I'm just looking for my snapshot button. I don't think I configured it properly. Maybe I did. Create a new snapshot. Snapshot 1. Error creating snapshot. Operation not supported. Okay, I misconfigured something. But never mind. It's not a very important virtual machine anyway. The command P is used to print the current partition table. The output is something like this. Dev SDA 111 gigabytes, bytes and sectors, disk model, sector sizes, disk label, type, disk identifier, and 2 partitions on it. So in my case, we have a disk model QEMU hard disk. This is my virtual hard drive emulator on Linux with some of the data about it. It's 20 gigabytes big. It has an identifier, and that's pretty much what we need to know at this point. Here is the meaning of each column. Device assigned to the partition. Where is the device assigned to the partition? When you have the partitions, but we don't have partitions just yet. Boot shows whether the partition is bootable or not. So these two are not bootable. Start sector where the partition starts. Maybe I should have do it on VDA just for the show. Yeah, so this is my live hard disk where I booted from. Partition 1, 2, and 3, where it is located and where does it end. And this one begins just after the first one, ends here, and the third one begins where the second one ends on this virtual hard drive. This is the size in sectors, size in megabytes and gigabytes, type of the file system, and this is everything that we can read from here. This is what the PDF is explaining. Sectors, the total number of sectors in the partition multiplied by the sector size to get the partition size in bytes. The size of the partition in human readable format. In the example above, values are in gigabytes. ID is the numerical value representing the partition type. Is it ID? It is ID. Okay, I didn't get it. I didn't get this in my version of the tool. The description for the partition type: primary versus extended partitions. On an MBR disk, you can have two main types of partitions, primary and extended. Like we said before, you can have only 4 primary partitions on the disk. And if you want to make the disk bootable, the first partition must be a primary one. One way to work around this limitation is to create an extended partition that acts as a container for logical partitions. You could have, for example, a primary partition, an extended partition occupying the remainder of the disk space and 5 logical partitions inside it. For an operating system like Linux, primary and extended partitions are treated exactly in the same way, so there are no advantages of using one over the other. Creating a partition. To create a partition, use the n command. By default, partitions will be created at the start of unallocated space on the disk. You will be asked for the partition type, primary or extended, first sector, and the last sector. Let's go back to our new hard drive. And let's type n for a new partition. And let's choose a primary partition by selecting P. Partition number, you can just press enter here. Actually, I'm just reading what the menu system is telling me. First sector, let's go from the beginning. I'm just pressing enter here. Last sector, okay. So this is where it gets a little bit tricky. So I'm pretty sure I know how to make a partition, but I always kind of avoided Fdisk wherever I could, simply because Fdisk is always available on pretty much every operating system, and it's a text user interface based tool, so you can just go up, down arrows. It's a little bit like a GUI tool, so it's much easier to work with. But we're learning Fdisk now. For the first sector, you can usually accept the default values suggested by Fdisk, unless you need a partition to start at a specific sector. Instead of specifying the last sector, you can specify a size followed by letters K, M, G, T, or P, like kilo, mega, giga, tera, peta. So if you want to create a 1 gigabyte partition, you can specify +1G as the last sector, and Fdisk will size the partition accordingly. I need something for demonstration. When you're making partitions on an actual hard drive, spinning Rust, this is a CD, but it is the only thing I have around at my convenience. So the beginning of a hard drive is usually in the innermost circle. I think I said it correctly. And the end is at the end, right? It spirals out towards the outside. Some of the mechanical properties of hard drive that may be important for you to decide where you want to put your partition is simply that the disk spins at a certain rounds per minute, usually 5,200 RPMs for slower drives, 7,200 RPMs, I think, for faster drives, and some ultra fast hard drives can be 10K RPMs. Not sure if I heard of 15K, but 10K I'm definitely sure that they exist. And the spinning speed decides on how fast the hard drive is, when you are copying a large file that is written in one go. I'm not sure how many of you know what fragmentation and defragmentation means. I'm going a little bit out of the tangent now from the lesson, but this, in my opinion, is important for you to decide where you want to put your partition. If it's a spinning Rust hard drive, if it's an SSD, it really doesn't matter. But if it's a spinning Rust, basically the hard disk is faster on the outermost edge, simply because the needle that basically sits like this, the needle goes like this, right? It just reads from the inner side and to the outer side, and the disk is spinning like this. Actually, you can't see it spinning. The disk is spinning like this. Leon says 15K was for SCSI and now SAS drives. Okay, but they do exist, right? That's the only thing I wanted to say. They do exist. So the reading head or the writing head sits like this, and the thing spins. And simply, if you can imagine the physics of the disk spinning at the equal speed, it means more data will pass on the outmost edge than on the innermost edge. So if you need some specific data to have a little bit faster speed, you might want to consider putting it on the end of your hard drive, because there it will be faster. Usually I was thinking about putting my swap partition on the outer edge of the hard drive, but it doesn't make too much sense at the end of the day, because swap is usually a lot of tiny data, and how much the head passes on the outside, it doesn't really matter, because on swap partition you have a lot of tiny stuff, so that kind of gets lost in the physics of the hard drive. So if you have a reason for defragmented data to be a little bit faster, you may want to consider putting it at the end of the hard drive. That's the only reason I can think of. Why would you want to think about why are you putting the partition at the beginning or at the end of the hard drive? And another reason why you may consider putting a partition on the beginning or at the end is the naming scheme. The first partition that you will make will have a designation of number 1. The second one will have number 2. So if the first one that you create goes into the beginning of the hard drive, it will get number 1. If you put the second partition that you're creating on the outer edge, it will get number 2. And if you put the third one in the middle, it will get number 3, because that's the third one that you're making. That's how these partitioning tools usually function, unless you can override it manually. But I don't think I have given you much stuff to think about, especially because nowadays everything is about SSDs. But if you're going to do any system administration or work with network attached storage, you will surely use hard drives a lot in your days. So I got these recently, a couple of them. So I'm still playing around with hard drives. They are very useful as terabyte per euro, right? Still cheaper than SSDs. Alexei asking, isn't it the other way? I always thought they begin on an outer side. I am pretty sure they begin on the inner edge. Let's ask the bot and then a normal search. The first sector of a spinning Rust hard drive is located at the outer edge of the platter, which would make me very wrong. This is consistent across manufacturers, as data is written to the outer tracks of the drive first, which also allows for the fastest data transfer when the drive is initially used. So we definitely agree on the physics. Neil Thompson, welcome in. It's my favorite YouTuber. Hello to the people. You can press the actual like button if you want. Is the first sector of the hard drive in the center or along the edge? Okay, let's go here. How many pop-ups do I really need? Why do I need to log in to answer? I have seen the answer, but where is the rest of this topic? This is the only, okay. I got confused by the number 5. It is located at the outermost edge of the platter, or one of the platters, if the drive has more of them. Okay, this is... What if the drive has more of them? Because I'm pretty sure that almost every 3.5-inch hard drive has more of the platters. The first sector is located on the outer edge of the first platter. Hard drives are designed to write data starting from the outermost tracks of the first platter and then move inward. Once the first platter is filled, data is written to the outermost track of the next platter and the process repeats. Okay, after learning this, you can pretty much forget everything that I said, because everything that I said is kind of useless because of what I just read. Leon Mertz says, pretty sure hard drives are written from the outside to the inside, but CDs are from the inside to the outside. Okay. I'm not sure the AI is correct. Marcus Sage, welcome in. It was a riot every now and then reinstall of XP. My friend had a compact server with SCSI hard drive. Modern drives access their sectors by logical number from 0 to sector count -1. LBA addressing. Sectors having adjacent logical numbers get grouped into tracks. Tracks are grouped into zones. Zone is a bunch of tracks, few thousand, residing on the same drive head. Then drive crosses the boundary of the zone. It switches to the next zone on the next head, in a way that head stack do not have to be moved far away, ideally not moved at all. This saves access time. Consider following primitive example of disk having 4 heads. Adjacent sectors are represented with sequence of letters of alphabet. When all zones, okay, different disk vendors have their own approach to LBA translation, but this is general idea behind the need of saving time on head stack moves. Also, the primary goal of introducing zones to hard drives back in the end of 1980s, beginning. Okay, I see where this is going. I'm trying to figure out something about the head stack. What does the head stack look like? Head assembly. But this is, I know about this, but this is just multiple heads reading, each one reading its own platter. That's fine, but I still count this as one head per platter side, right? So if you have 2 platters, you will have 4 heads naturally, but I'm thinking about what the head stack would be. Maybe I should disassemble one of my hard drives. This one is pretty cool, but I still count this as one head per platter side. I'm a bit confused about this part. When drive crosses the boundary of the zone, it switches to the next zone on the next head in a way that heads stack do not have to be moved far away. Ideally not moved at all. So what this text is telling me is that what you can see on the screen right now, it's like one head moving left and right all of the time and just doing this. And what this guy on Quora is saying sounds to me like you have like multiple heads that spin, not that spin, but move left and right just a little bit because there are like more of them in parallel. That's how I imagined it, but I'm not actually sure. What is this guy saying? Also, the primary goal of introducing zones was effective utilization of different track lengths due to the fact that inner tracks are shorter and outer tracks are longer. When you keep linear bit density on the same level of all tracks, you get different number of bits being recorded on inner and outer tracks. This concept is called zone bit recording. Okay, so my biggest mistake was obviously mixing up CDs with hard drives. But if you excuse me on this error, it seems to be not very important where you write your data to, especially on regular sized hard drives because you have multiple platters stacked together. So I'm not sure if you have two platters together and you have 3 heads, right? Or 4 heads. Let's say 4 heads. Each head is writing on the on one side of one platter. So is it filling up the outermost edge of the both platters at once? Or is it filling up the first platter first and then the second one? I have no clue. That kind of remains to be seen. Alexei thinks the controller writes to each plate's stripe sequentially and then goes to the next stripe. This way, reading from start to end is one full head move. Otherwise, it would be n times, where n is a number of plates. So even with multiple plates, it's still faster at the beginning of the drive. I mean, as far as I understand, hard drives can only read one data at a time. So I don't know. It's still very important to have your drive defragmented if you keep large data on it. But if you keep very small data on it, I don't think anything will save it from seek time. Okay, let's create our first partition. I have typed the N letter, then we have chosen the primary partition, then we have chosen the first one, not any of the other ones. First sector that was being offered, and we're going to do the plus 1 gigabyte. Created a new partition 1 of the type Linux and of the size of 1 gigabyte. And if we print the data on our hard drive now, it's still not written, but if we write it, it is going to be like this: SDA1 from start to end, sectors 1 gigabyte. Alexei says, in fact, it would be 2 times n minus 1, since head would need to move back to the outer edge. Neil Thompson, in 10 years, nobody is going to be talking about any moving parts in electronics. Maybe. I think it depends on the price and the availability. I mean, the hard drives are still cheaper than SSDs if you do not require anything faster. Just saying. Also, some of the SSDs, or I'm not sure if it's the entirety of the SSD technology, but I have heard that SSD can start losing data if it's not plugged into the power supply for a very long time. For example, you leave it stored in your drawer like for more than a year, there is a small chance that it is going to start losing data. Now, you need to verify this after me saying it, because I'm not entirely sure, but I'm totally unwilling to test this theory on my SSDs. Just saying, for a cold storage, it may be a good idea to verify this. I mean, the reason why I purchased 8 terabyte hard drives is because I paid 100 euros for these guys. I'm not sure that I could get an SSD that has DRAM memory on it. This is important, and being 8 terabyte for the price of this, and the speed is pretty irrelevant for what I use these drives. Neil Thompson says, by the next 10 years, any SSD data loss in storage issues will be resolved. CRT monitors are super cheap right now, but who is even considering using one? That would be me. That would be me. Don't get surprised when you see weird stuff on this stream. Neil Thompson says, whoa. Yeah, important part of my desk. So if you want to create a 1 gigabyte partition, you could specify +1G as the last sector, and Fdisk will size the partition accordingly. See this example for the creation of a primary partition. We already went through that live. Checking for unallocated space. Let's write this. Let's write this. The partition table has been altered. Disk has been synchronized. If you do not know how much free space there is on the disk, you can use the F command, I suppose the capital F, command to show the unallocated space like so. Let's do the capital F. Oh, I didn't realize that the tool has exited. Unpartitioned space, 19 gigabytes. From this sector to the end. Okay, deleting partitions. To delete a partition, use the D command. Fdisk will ask you for the number of the partition you want to delete, unless there is only one partition on the disk. In this case, this partition will be selected and deleted immediately. Be aware that if you delete an extended partition, all the logical partitions inside it will also be deleted. So let's go ahead and attempt to delete one of my partitions where there is only one. D, partition 1 has been deleted. Voila. Bye-bye. Mind the gap. Keep in mind that when creating a new partition with Fdisk, I have been to London recently, so that kind of stayed in my head for the tube. When creating a new partition with Fdisk, the maximum size will be limited to the maximum amount of contiguous unallocated space on the disk. Say, for example, that you have the following partition map. 1, 2, 3. This one starts in the beginning and here. Let me see, what number of sectors is this? Okay, so this would be like 1 million. And the next one starts right after this one. And here and the next one starts right after that one and ends here. Do we have more? No. Unpartitioned space, 800 megabytes. It says we have a part of the space here and here. Did I miscalculate it? Let's check one more time. It says that we have one part of the free space from 105, 624, 624. This is incorrect. This is wrong in the PDF. Do you guys agree with me that this is wrong? This part is correct. This one is not correct. Or I'm blind. Does anyone else think that this is wrong? Then test it. I can't test it because this is not my hard drive. No, Zoran, you don't understand the reason why I cannot test it, because you need to make the partitions. I suppose I can test it. I suppose I can. Okay, let's do what you said. Let's do what you said. Partition, right? Or no, new one. New one, primary one, first sector. On your second VDA? No, on my SDA. On my SDA, size plus 512M. New one, primary 2, first sector 0624. 0624, yeah, okay. Last sector plus 512M. New one, primary 3, first sector plus 512M. Yeah, and let's write it and go back here. And how do we list it? P. Okay. Do we agree that this is literally the same? Do we agree that this is literally the same as in PDF? All of the sectors are completely the same. Yes? So why I said that this is false is because the PDF claims, I will get to the capital F soon. The PDF claims that there is 500 megabytes of free space between this sector and this sector. But this cannot be true, because on this sector we have the second partition starting. 105.06.24. 105.06.24. This is where our second partition starts. And this output claims that we have free space here. So let's go and type F. And voila, exactly what I told you. I mean, I'm not pretending to be smart. I'm just noticing the error in the PDF. If you delete partition 2. Okay. You should have told me that immediately. You should have told me that immediately. Delete 2, F deleted, F. Okay. Now it makes sense. Now it makes sense. I mean, this is why I have you guys. Without you, this lesson is a failure. I'm just saying. Things are being heated up, and I'm actually quite hot in this room, and I'm not allowed to open my window because you're going to start hearing cars. Riam, welcome in. Cake is lie. Riam says I forgot my Mint password. I'm just gonna open my doors of the room. I'll be right back. I'm spoiled already with ZFS. That's a good spoil. Adding up the size of the unallocated space, in theory we have 881 megabyte available. But see what happens when we try to create a 700 megabyte partition. It cannot be created because there is not enough space in one go. New partition, primary, number 2, default, and +7. I can't do that. I can't do that because I have enough space. I have enough space, unlike them. 700 megabytes, value out, last sector, value out of range. It's out of range. Okay, actually I can reproduce. I thought that I'm going to put it at the end of the hard drive where there is space, but in fact there is no space here. Okay. I'm rushing it, but you only have a space of 500 megabytes. Yeah, there where I am putting it right now. So I can put plus 512 megs. I guess we can't fit that either anymore. Plus 511. Now it fits. In this case, it would be better to type a last sector number so you can get it all the way up to the end. This was stupid, what I did. This was stupid, and the reason for that is because now I have 1 megabyte of free space. Yeah, we did. All good. This is a part of practice makes perfect. That happens because the largest contiguous unallocated space on the disk is 512 megabyte block that used to belong to partition 2. Your new partition cannot reach over the partition tree to use some of the unallocated space after it. Changing the partition type. Let's write it down first. Right. Okay. Occasionally, you may need to change the partition type, especially when dealing with disks that will be used on other operating systems and platforms. This is done with the command P, followed by the number of the partition you wish to change. Let's do that. P and default, so it goes from the back side. Okay. Hex code or alias. Type L to list all. Let's list them all. So, did we skip something? Yeah, we did. Okay, so there is a bunch of partition types here. Aliases. Linux is 83. These numbers are something that you are actually going to use quite a lot in the Linux world. A damn trap, I have never done it. I have never done this. If it comes to it, I write new partition table. New partition table. You have never fit a new partition in between the two of the existing ones. It's not actually a problem. Let me what do we have? What do we have? Print delete number 2 has been deleted. A new partition primary number 2 first sector is the default one. Last sector is the default one. Yeah. And now if we type F, now we have one continuous free space of 18 gigs, and no megabytes have been lost. So if you want to be precise, you can just use the correct sector number to align your partitions against. You never changed partition type. Oh, that's odd. That's odd. You need to change partition types if you are... I mean, I'm kind of lost. What do you mean by that? If you're using Fdisk, clearly the default partition type is already being set as 83, and you wanted it to be something else for Windows. So you have to change it. Maybe you have used a different tool that would ask you which partition type is it in one go. Maybe that's how you did it. But I'm just going to go and step out of the Fdisk just for a bit to show you another tool that I always use, but it's pretty much the same as Fdisk. Right. Just add the letter C to Fdisk, and then you get it like this. Let's increase the size so you can see it better. So this is basically Fdisk, but it gives you a visual representation of what you're doing. It's easier for the brain to work with this. You can do all the same stuff. It's just easier to look at, and this is available on I think every Linux distribution. On Arch Linux, install Medium for sure. On Debian, install Medium for sure. For other Linuxes, I have no idea, but I'm pretty sure it's everywhere. When you create a new partition, you go to the free space, you press enter for new, right? You can see where I am on the bottom. You press new, partition size 1G, you say it's primary, and it's been created. It's already of the type Linux. So already you have to change the type of the partition, right? And here type, you press the type, you get a nice looking menu. You're going to make it, I don't know, FreeBSD partition or Windows. Where is Windows? DOS, no. Somewhere in the beginning, FAT 16, there we go, FAT 16, FAT 32. Where is, let's go with FAT 16, just for shits and giggles. Yeah, so I have changed the type of the partition because I had to. Also, if you delete this partition and you delete this partition and you're creating a new partition that is, I don't know, 8 gigs large, primary, you may go to the type and switch to 82, which is Linux swap, but still you have to change the type, correct? Let's go ahead and quit, go back to Fdisk, print our partitions. So because I haven't saved what I was doing in the GUI application, we are now back to our 3 partitions, each one half a gigabyte. All of them are of the type Linux. So let's press the T button to change the partition type. And let's go ahead on the partition tree, a hex code or alias. Let's type number 82. This is Linux swap. And you have changed the type of partition Linux to Linux swap. And you can print it out again to see that indeed we have swap over here. You misunderstood the topic. That's fine. That's fine. But you have to be able to change the partition type. Let's write this down. Now that we have created Linux swap partition, just for shits and giggles, I'm going to skip a little bit and then go back to the lesson. Htop. We have 976 megabytes of swap. So our new swap here is half a gigabyte, and it is SDA3. So mkfs dot swap, is it not that part? Mkswap, okay, I forgot the command. Mkswap dev SDA3. I think this is it. We have made dev SDA3 as swap. And if you go back to see your swap memory, it will still be just 1 gigabyte here. See, it's just 1 gigabyte because it's still using our primary swap partition for swapping. But there is a command swap on dev SDA3, and we have now enabled the second swap partition. And if you go back to Htop, you will now see that we have 1.5 gigabyte of swap here. So if you happen to design your hard drive partitions before you install your operating system, and you're really tight with the space, but you need more swap, you can just add more of the swap partitions. That's all what I wanted to say. It doesn't have to be just one swap partition on just one position. You can have, if you have multiple hard drives, you can put multiple swap partitions on multiple hard drives, and in theory, you will get slightly faster swap simply because multiple hard drives are able to access the physics of themselves at the same time. So this is something that's kind of good to think about, but not necessarily super important. I'm just sharing what I have been doing throughout the years. Also being mistaken about where the hard drive speed starts, but it is what it is. A partition type must be specified by its corresponding hex code. Neil Thompson says, a few months ago, DistroTube recommended 6 smaller YouTube channels that we should all check out. I subscribed to 4 of them. 4 of them, now only 2 remained. Linux Renaissance is by far my favorite. Thank you very much. Can I attempt to guess that the other one is bread? The partition type must be specified by its corresponding hex code, and you can see a list of all the valid codes by using the command L. Do not confuse the partition type with the file system Brad Pitt on Linux? No. Now you got me confused. What her channel name is? Bread on Linux? Bread on Penguins. You got me confused by Brad Pitt. Bread on Penguins. I'm just guessing that's his other kept channel. Do not confuse the part with the with partition type with the file system used on it. You got it. It's Brett, who is a command line master, but she's always doing things I really have no interest in doing. I think the essence of any creator, and when I say creator, I don't mean YouTuber. I mean anyone with any kind of imagination or no, that's the wrong word. Anyone who is creative, not by making videos on YouTube, anything at all in life. Anyone who is creative, they have that's something that makes them what they are, right? And they get like people who are interested into this personality and what these people do. So as much as I'm unique, that much she's unique. And basically watch her because she's interesting in her own way. Which is not something that I can say for YouTubers with 300,000 subscribers. They kind of start falling onto the generic category. Not all of them, but they do tend to gravitate towards what the algorithm tells them they must do in order to survive. All YouTubers are unique personalities. Yeah, I'm just some of them kind of stop being unique at some point when they smell a lot of money. I certainly hope I do not follow their steps. And for the third time, do not confuse the partition type with the file system used on it. Although at first there was a relation between them, today you cannot assume this to be true. A Linux partition, for example, can contain any native Linux file system like ext4 or a Riser file system. And I'm very, very amused that the PDF being updated in the year 2025 is mentioning a Riser file system along with ext4. I'm not saying this is wrong, this is correct. I'm just saying that this is amusing. Tip, Linux partitions are type 83, swap partitions are type 82. Managing good partitions with Gdisk. Here, Streamlabs thinks you should drop me a coffee. I'll drink to that because it is a coffee. Isn't Fdisk now capable of dealing with GPT as well? That's what I thought when I saw this, but this is a document from this year. So by the way, if anyone wants to get a link to the rest of my video on demands, you can type in chat !LPIC and the bot will provide you with the link. The utility Gdisk, it's not even installed. Rankoa just subscribed. Thank you very much. The utility Gdisk is the equivalent of Fdisk when dealing with GPT partitioned disks. Let's go ahead and I am a bit torn in between proceeding with as the lesson says or telling this lesson to FO, because we can do it with Fdisk as well. Cool funky graphics there. It's Streamlabs. Let's make another hard drive. Let's make another hard drive, add hardware. Let's make it 10 gigabytes. Disk device. What if we make it like, I don't know, 5, or what did they say that MBR can only go up to 2 terabytes? Let's make roughly 3 terabytes partition. SCSI, so it will end up being SDB. Finish. Oh, damn. That's not what I wanted. Can you guys please wait 230 hours? I'm in trouble. I am in trouble. How do I stop this? Kill the process? Yeah, I think we are going to have to do that. Let's add... we can't add nothing. Damn! Damn, let's kill the process. Image create. Kill it. Could not create storage. Okay. We killed it. Press the reset button. It killed itself. No, I killed it with the htop. Let's make a hard drive once again. Wait a second. How many hard drives do we have now? Disk 1, disk 1. Select existing. Is this 2 terabytes already? I'm confused. I have just chosen. Okay, let's do it again. What is the timeout thing? What was the name of the hard drive? lpic demo 2. That's the one that we have created. Okay, let's do it. 10 gigabytes. SCSI finish. Close. lpic demo. Oh, okay. So we have SDA with our 3 partitions. And now we have SDB, but we also have SDB is the one that I failed in adding. Let me unplug that one. SCSI disk unknown. Remove. Delete. Fine. Okay. Let's do it again. Okay. Our second drive is now SDC. It is what it is. It could become SDB after reboot. Not sure. Not sure. But for now, it's SDC. Neil Thompson says he uses old Canon printer. It's the most honest electronic device ever. Its wait message is please wait a while so the user can go make supper. Okay. Gdisk dev SDC. Okay, it is starting to initialize our disk. Make this smiley says excellent. Print the current partition table. The command P is used to print the current partition table. The output is something like this. That's for the existing disk, but let's make a new one. So I have started Gdisk on dev SDC and it wants to initialize it. Partition table scan, no partition table found. Creating new GPT entries in memory. So it had already started making it a GPT disk, okay, by default. We will get a similar data about our hard drive as with Fdisk. Right from the start, we notice a few different things. Each disk has a unique disk identifier. Good. This is a 128-bit hex number assigned randomly when the partition table is created. Since there are 3.4 times 10, how do you read this in English? I can read it in Croatian. In Croatian we say 3,4 puta 10 na 38. So if in English you don't say this 3,4 puta 10 na 38, then how do you pronounce this in English? I have no clue. To the power? Okay, to the power of 38. An effing lot. Since there are effing lot of possible values to this number, the chances that two random disks have the same GUID are pretty slim. The GUID can be used to identify which file systems to mount at boot time and where, eliminating the need to use the wise path to do so, like dev SDB. One of the most practical thing about the disk identifier, which may be the reason why they are doing it, but it is from the practical standpoint, is when you look at the fstub file. Let me go ahead and write this. Yeah, why not? So in fstub file, you will see that this disk with this UID is mounted as a partition boot, while this UID is mounted as boot FE. And then we have some other stuff that we mount. But generally, what is practical about this is that you can be sure that as a boot partition, you are always mounting this exact partition. So, for example, with the old MBR partitioning table, which was fairly common on the previous system, if you would swap the SATA cables on the motherboard and then boot up the computer, I'm not sure if this would happen every time, but I'm pretty sure it would swap the names of the partition. But we can actually test this here. We are still on LPIC demo, correct? ls block. So we have SDC partition here. Let's reboot this computer. I'm not entirely sure, but I would expect this disk to simply rename itself to SDB. Ako ti smeta moja buka, slobodno zatvori vrata, meni je bilo vruće. Sudo dash I. Oh, even better. So the one that was SDA, and it was the first hard drive that I added after this one, has now moved to SDB, and the one that was SDC has now moved to SDA. So let me go back to this one. So when I was younger, we didn't have UUIDs. We would just mount dev SDA as our root partition, dev SDB as our home, dev SDC as our swap, stuff like that. And then you add another hard drive, and then these drive letters get mixed up, and then you're in trouble. It works the same. It works exactly as in the MBR partitioning scheme. But when did I add that up? We didn't have this. We didn't have disk in the. What did I just say? Did I just say Fdisk? We didn't have this sometimes before. I clearly remember that all of my Linux installations have had only dev HDA, HDB, stuff like that on the FS tab. When did I add this? So this is then a part of the kernel, correct? I think it's parsed by mount. Your sound has some background noise. Okay. No, it's when I think and talk, I get focused on either thinking or talking. I don't listen to the sounds around me. But I have had my room doors open, and now I have more people in the house, so they're doing the house things and making some noises. So it's probably them. And now I have closed the doors again, but I will overheat soon by closing everything in this room. I also have the window closed. If I open the window, then you will hear cars. Uh, I'll guess I'm just gonna have to believe this, but I have used dev HDA, HDB, and then SDA, SDB for quite a long time, even in FSTab. You do not mind the cars? Okay. If you get annoyed by the noise, which is not present at the moment. Let me know. I'll close it again. One car just passed. The GUID can be used. You heard nothing? Yeah, I have noise gate. Some cars you can only hear when I'm talking. Others you will hear without me talking. The noise gate is good. Okay. The GUID can be used to identify which file systems to mount at boot time and where, eliminating the need to use the device path to do so, like dev sdb. What did I mix up here, Alexei? Disk identifier is good. The GUID can be used to identify which file systems to mount at boot time and where. Either I am mixing something up or this PDF is confusing me again, so I'm gonna need some of your help. This kind of doesn't add up. See the phrase partition table holds cman mount. File system universal unique identifier. The format of the UUID is usually a series of hex digits separated by hyphens. See also dash capital U. Note that mount uses UUIDs as strings. The UUIDs from the command line or from fstab are not converted to internal binary representation. The string representation of the UUID should be based on lowercase characters. Fine. But the GUID can be used to identify which file systems to mount. Are they sure that they are talking about GUID and not UUID of the partition? Because here we are discussing disk identifier. I think this is what confused me, but now I'm still not sure. GUID is partition, okay? Okay. Okay, needs a little bit clearing up, I suppose. CD phrase partition table holds up to 128 entries. That's right, you can have up to 128 partitions on a GPT disk. Because of this, there is no need for primary and extended partitions. The free space is listed on the last line, so there is no need for an equivalent of the capital F command from Fdisk. We have nothing here. Let's, Alexis says, so you can mount file system with UUID or partition with GUID. All right. All right. Let's create one partition just for the fun. New one. It's offering 1 to 128. Default is 1. Size, let's make it plus 1 gigabyte and plus 1 gigabyte. This should be fun. Xcode or GUID. Linux file system. That's the default one. 8300. So it's the same. I never really thought in this way, but apparently it's the same number, just with 2 more zeros here for the simplicity. Q to quit. Xcode or GUID. I'm just gonna press enter to get the 8300, and we are done. We are done. Okay, so this one starts at the after 1 gigabyte of free space and ends up after another gigabyte of free space, and its size is 1 gigabyte. And so they say that the capital F is not needed. It's not needed. Okay. It's not needed because the free space is listed on the last line, so there is no need for equivalent of the F command from Fdisk. I saw that, but on the Fdisk, free space lists all of the free spaces, you know, so I kind of think it would be useful to see where the free spaces are. Because on this disk, we have 2 free spaces, one before the first partition. That's why I moved it, and one after the first partition. So it should have shown 2 free spaces. But okay, let's write this down. We want to proceed. Yes. Yes. The command to create a partition is n, just as in Fdisk. The main difference is that besides the partition number and the first and last sector or size, you can also specify the partition type during creation. GPT, during creation, okay. GPT partitions support many more types than MBR. You can check a list of all the supported types by using the L command. We did that somewhere above, but to see more, I didn't list them all. To delete a partition, type D and the partition number. Unlike Fdisk, the first partition will not automatically be deleted if it is the only one on disk. On GPT disk, partition can be easily reordered or sorted to avoid gaps in the numbering sequence. To do this, simply use the S command. For example, imagine a disk with the following partition table. Let's use the S command immediately. You may need to edit XFS tab or your bootloader configuration. Why? It's a new hard drive. Why would I need to edit any of these two? Sort partitions. Why can't I sort my partitions? I have partition 1. I want to make it a partition 2. Why wouldn't this be a partition 2? Why is it bothering me to edit XFS tab and bootloader? This doesn't make too much sense. This is my spare hard drive. I don't want it in my FS tab. I don't want it in my bootloader. I just want it to be a hard drive that I sometimes mount, sometimes not. And I want this partition to be number 2. On GPT disk, partition can be easily sorted. Imagine a disk with the following partition table, 1, 2, 3. Let's make another one. Let's make another one. This one will be 5 plus 6G plus 1G. Write this down. Okay. Now I have partition 1, partition 5. They are at complete different spaces, not touching each other. We have some free space. Can we now reorder? We still cannot reorder anything. That's a bit odd. Backup GPT data, change partition name, delete partition, show detailed information, list partition types, add partition, create a new partition table. It did reorder. Oh. I was expecting it to give me the ability to reorder. I thought it would give me a chance to pick different numbers. But okay, if you delete the second partition, the table would become 1 and 3. That's what we had just a moment ago. If you use the S command, if it would be 1 and 2. Okay, notice that the third partition became the second one. Gap, what gap? Unlike MBR disks, when creating a partition on GPT disks, the size is not limited by the maximum amount of contiguous unallocated space. You can use every last bit of a free sector, no matter where it is located on the disk. Okay, to be honest with you, I did not know this. I really did not know this. Recovery options. Let's create, so the beginning of my hard drive has 1 GB of free space. Let's test this. Partition number 3, first sector, default. Is it 34? First usable sector is 34. Okay, let's do the 34. And the size can be 1 GB maximum. So let's make it, I don't know, 4 GB. It doesn't want to. How many free space do we have? 8 GB. Let's interrupt this. We have 8 GB of free space. Let's create a new partition. It will be number, I don't know, 66. And the first sector, I will make it default. And the size will be plus 8 gigs. It doesn't want to. What about plus 7 gigs? It doesn't want to. Let's just press enter and see what we got. We got 6 gigabytes. Sounds more like LVM. Yeah, but LVM doesn't depend on GPT or MBR. It doesn't care, as far as I know. So I have 1 gigabyte here, 1 gigabyte here, and 6 gigabytes in the middle. Definitely 1 gigabyte is free space before the first partition. Between the first one and second one, there is nothing. So there must be another gigabyte after the third one. I'm not sure what they mean about this. I'm just gonna copy paste disk to the silly bot. Let's see what the bot says about this sentence. Do not impose a size limitation based on the maximum. This means it's just repeating after me. Windows GPT questions. Well, I'm not sure about this. I'm not sure about this. I really wanted this to be true because I didn't know that I can do this. That's why I had to try it, and it doesn't work. Recovery options. GPT disks store backup copies of the GPT header and partition table, making it easy to recover disks in case this data has been damaged. Gdisk provides features to aid in those recovery tasks, accessed with the R command. Recovery and transformation options. Rebuilding, backup, hybrid MBR, convert GPT into MBR and exit. Verify disk. Okay, let's write it down once again and go back to see. Good. You can rebuild a corrupt main GPT header or partition table with B and C respectively, or use the main header and the table to rebuild a backup with D and E. Alexis says GUID partition entry format has only first and last LBS, so the PDF seems to be wrong. You need logical volume management for such flexibility. Yeah, but logical volume management is like a level above partitions, right? In the sense that LVM also needs to have some partitions underneath, so it can sit on them, and then you know, I mean, we did that already on these streams. So you still need row partitions in these free spaces, and then you can put one LVM to join them. I'm just saying that you don't need GPT for LVM. You can also convert a MBR to a GPT with F and do the opposite with G, among other operations. Type question mark in the recovery menu to get a list of all of the available recovery commands and descriptions about what they do. So we already went through that. We can do it one more time. Use backup GPT header, load backup partition table from disk. Use main GPT header for rebuilding backup. Load main partition table from disk. Load MBR and build fresh GPT from it. Convert GPT into MBR. Make a hybrid MBR. I don't know what this is. Show detailed information on a partition. Load partition data from a backup file. Return to main menu. Print protective MBR data. Print the partition table. Quit without saving changes. Transform BSD disk label partition. Verify disk, write table to disk and exit, extra functionality experts only, and stuff like that. Transform BSD disk label partition. I wonder if this is like a universal BSD thing, or do they mean the old BSD or the new? Which BSD do they think this belongs to, or is it all of them? I'm just asking because when I installed FreeBSD and OpenBSD, the partitions looked vastly different. Especially that OpenBSD names their partitions like C, D, E, like Windows does it, but that doesn't concern the partition table. So maybe the partition table is the same. Alexis says, I meant to use all the free space no matter where it is physically located on disk. I guess they meant BSD style slices, as they call it. Perhaps. Creating file systems. Partitioning the disk is only the first step towards being able to use a disk. After that, you will need to format the partition with a file system before using it to store data. A file system controls how the data is stored and accessed on the disk. Linux supports many file systems, some of them native, like the extended file system family, while others come from other operating systems like FAT from MS-DOS and TFS from Windows NT. HFS is I forgot the full name of HFS. Never mind. That one, those ones are from the old Mac operating systems. The standard tool used to create a file system on Linux is mkfs, or for the English-speaking people, mkfs, which comes in many flavors according to the file system it needs to work with. So creating an extended file system. This was the first file system for Linux, and through the years was replaced by new versions called ext2, ext3, and ext4, which is currently the default file system for many Linux distributions. As far as I remember, the ext2 and 3 are actually the same, with the difference being that ext3 brings in journaling, which can be disabled if you mount the ext3 partition on an older kernel which doesn't support ext3. You can just mount it as ext2 and it will work just fine, but the journaling will be offline at the time. I'm not sure about how backwards compatible ext4 is. Can you mount it on an old kernel which supports only ext2? I would say no, but that's just a guess. The utilities mkfs.ext2, .ext3, and .ext4 are used to create these file systems. Alexei says, no, it's not backwards compatible. Okay, thank you. The only reason why I remember this is because I have had hard drives with ext3 partitions, which I was in the opportunity to mount in a different computer, which only had an older kernel with support for only ext2. So at the time, this was necessary, at least a necessary knowledge that you can mount these partitions as ext2 partitions. In fact, all of these utilities exist only as symbolic links to another utility called mkfs. This utility alters its defaults according to the name it is called by. As such, they all have the same behavior and command line parameters. The most simple form of usage is mkfs.ext2 and then the target partition. So let's go ahead and play with it for a moment. Let's make this one as like ext2 partition. mkfs.ext2 dev sdb1. Let's make this one ext3 dev sdb2. And the last one will be ext4. This one is a swap file system. Do you wish to proceed anyway? So Linux will allow you to put a file system that does not correspond to the partition type, and this actually will work, but I actually don't know what is the true reasoning, or maybe it is something historical, but I'm just going to show it to you. Proceed anyway. Yes. Okay. So right now I cannot see it here. If disk dev sda. Did it? SDB, sorry. SDB. Yeah, so the last one is marked as swap, but I have formatted it as ext4. Let's go to mount mkdir sdb3 mount dev sdb3 to sdb3. So this one is mounted. Let's go in there. SDB cd sdb3 touch something. Okay. And if we do the mount command grep sdb3, you can see that sdb3 block device is mounted on this path here, and the type of the file system is ext4, and this functions just fine. Let's unmount sdb3 and let's go to Fdisk once again. Fdisk dev. Actually, let's use the Gdisk dev sdb. What was the command to change the type? Was it T? Partition number 3. Let's change it to 8300, and we have changed the type to Linux file system. Let's write it again. Yes. Okie dokie. Now let's mount our partition again. Stop. You want me to stop? It doesn't matter if I ruin something. I stopped. SDB was MBR, or at least it was. Can Gdisk work with MBR? Found invalid GPT and valid MBR. Converting MBR to GPT. Okay, that's what happens when you rush it. In memory, this operation is potentially destructive. Yes, I would advise everyone to read what your tools tell you before writing. But as I said, I'm just doing this on a machine that doesn't matter. So it's actually good to see what happens and how do I destroy it. Let's go ahead and mount, not mount, I meant Fdisk dev SDB. Yeah, it's definitely GPT now. It's definitely GPT, but that doesn't matter that anything got destroyed. It just got converted to GPT. At least that's what it looks like. Let's mount dev SDB3 to SDB3 and ls. Yeah, so we still have something as a file in this partition. So that's kind of good. That's good. Now let's unmount. You definitely should do demos on your Arch host machine. Definitely, yes. Yeah, I mean, the reasoning why I switched to a demo machine is because of all of the scenarios where I rush things. But also, if I wouldn't rush things, then we wouldn't have this chance of random repairs. I think random repairs are a solid way to learn things, especially because probably none of you is going to rush things on your actual computer, and even less so on a server. So let's play with conversions. Unmount SDB3. So this conversion kind of succeeded without me even realizing what it did. So now we have GPT. Let's go ahead and Gdisk dev SDB once again. So this is GPT. Okay, now where was the advanced stuff? Experts only, R. Good name for a repair shop, random repairs. Let's go to the R menu and see how do we convert it back to MBR. Convert GPT into MBR and exit. Okay, so that's G. Toggle the active boot flag, recompute all CHS values, set partition as logical, omit partition, print the MBR partition table, set partition as primary, sort MBR partitions, change partition type code, write the MBR partition table. Can be logical, can be primary. What if we just write it and do not decide anything else? Let's just write it down. Converted tree partition, finalize, yes. GPT data structures destroyed. You may now partition the disk using Fdisk or other utilities. Really? Let's do the Fdisk. GPT data structures destroyed. Okay, I understood that part and expected, but this one confused me. You may now partition the disk using Fdisk. It's just saying that you can now use other utilities. This is Gdisk crying that I'm leaving him. Nothing else. Okay, let's mount dev sdb3 to sdb3 ls. So something is still here. Apparently we can convert from MBR to GPT with no trouble, and we can convert it back with no trouble, but I still would not recommend doing this on anything production. Make your backup first, then do the conversion. Always make a backup. Always make a backup. I'm not kidding. Always make a backup. There was something else that I wanted it to do. Unmount. Should I make a backup? Yes. Definitely yes. Man mount. How do I select the file system type with T? The T and the file system type, the most common are, okay. I always rely on automatic file system detection, so I kind of forgot what the switch was, but now I want to override this. Once again, Fdisk dev sdb. Here, yes. If you go where my mouse is, you will see that file system is x2, just in case you forgot. This one is x3 and this one is x4. Okie dokie. So let's mount -t x4 dev sdb3 to sdb3. Good, works. Now let's unmount it. Okay. Now let's mount it again as x3. I would expect this not to work. Wrong file system type, bad option, bad superblock, and stuff like that. So let's mkfs. Actually, we have already made file systems. Let's mount -t x3 dev sdb2. That sdb2. That's the one that is really formatted as x3. Let's put that one on. It can go to sdb3, doesn't matter. Mkdir sdb. It will be confusing if I do that. Unmount sdb3. Let's mount it again to sdb2. Let's touch sdb2 x3 something ls sdb2. So right now in the sdb2 folder we have a file called x3 something, and mount grep x. You can see this is our x3 partition. Now let's unmount it sdb2. Let's mount it again on sdb2. Let's mount it again on sdb2, but let's change the file system type to x2, and you can see that it actually mounted. ls sdb2, you can see here is our file, And if we mount, you can see that we have a partition mounted as ext2 file system. That's all I wanted to show you. It's not very relevant in 2025, but ext2 and 3 are backwards compatible. It's just that right now, journaling functionality of ext3 file system is no longer active. It will become active right after you mount it as ext3. Unmount SDB2. Good. There is one thing I never tried. Mount SDB1 as ext2. This is fine because that is ext2 partition. Touch SDB1 ext2 something. Now let's unmount it, SDB1. Let's try to mount this as ext3. I know it can be converted because I have done the conversion myself previously. I don't know if I can just mount it like that. Yeah, you can't. You can't. You have to convert it first. Instead of using the command corresponding to the file system you wish to create, you can pass the t parameter to mkfs followed by the file system name. For example, the following commands are equivalent and it will create an ext4 file system on SDB1. So mkfs.ext4 or mki2fs -t ext4 and then the same target. Command line parameters. This utility supports a wide range of command line parameters and options. Here are some of the most significant ones. All of them also apply to mkfs.ext2, mkfs.ext3, and mkfs.ext4. bsize set the size of the data blocks in the device, which can be 1024, 2048, or 4096 bytes per block. Try make I think the -t would override. I think the -t would override and it would actually make an ext3 partition. C checks the target device for bad blocks before creating the file system. You can run a thorough but much slower check by passing this parameter twice, as in make file system -c and then target. Unless they specifically check for that, Alexei says, talking about the clash of the two commands. mkfs.ext4-t ext3 dev sdb2. Dev sdb2 contains an ext3 file system. Proceed anyway. Okay, I think this is a regular warning me that I already have a file system. What did we do? What did we do? Which one was it? SDB2. Yeah, it did. It did override with -t. Okay, so with -c you can check before making the file system. We could actually try to do that. -c, yes. It kind of finished very fast. Let's do it twice. Okay, now it's thoroughly checking. It shouldn't be too long because it's an SSD and the partition size is very small. Okay. D copies the contents of the specified directory to the root of the new file system. Useful if you need to pre-populate the disk with a predefined set of files. And this one I didn't know. This could be useful for various scripting. -F, Danger Will Robinson. This option will force the utility create a file system even if the other option passed to it or the target are dangerous or make no sense at all. If specified twice, as in F and another F, it can even be used to create a file system on a device which is mounted or in use, which is a very, very bad thing to do. Let's add one F here, so it didn't ask any questions. That was expected. Press F to create a file system. Alexei says -L volume label will set the volume label to the one specified in volume label. This label must be at most 16 characters long. Can I see it here? No. File system label lpic. -N is a truly useful option that simulates the creation of the file system and displays what would be done if executed without this option. Think of it as a trial mode. Good to check things out before actually committing any changes to disk. Let's do it again. Let's put it somewhere here. So it doesn't really say that it is demoing the change. Maybe because there is an F here. It doesn't feel like it didn't do the thing. Let's make it ext4. Yes. So we kind of made ext4 on the dev SDB2, and it's still ext3. Yeah. It does. The n, the dash n works. It just doesn't say anything. It doesn't announce itself. That's too bad. Quiet mode will run normally, but it will not produce any output to the terminal. Useful when running it from a script. Let's do that. Dash Q. Okay, but we need dash F as well, so it doesn't ask questions. What did I do wrong? This one is unnecessary. Is it not supposed to be quiet? Quiet mode. But it's not that quiet. I mean, it did omit some of the output, but not everything. Let's put 2 Qs. Nope, doesn't work that way. Okay, so it's not quiet, it's just quieter. Dash U and the ID. This will set the UUID of the partition to the value specified as ID. UUIDs are 128-bit numbers in hex notation that serve to uniquely identify a partition of the operating system. Did we not say that UUIDs are file systems identifiers and not partition identifiers? Seriously. This number is specified as a 32-digit string in the format as shown on the screen, meaning 8 digits, hyphen 4 digits, hyphen 4 digits, hyphen 4 digits, hyphen 12 digits, like this. Instead of an ID, you can also specify parameters like clear to clear the file system UUID, random to use a randomly generated UUID, or time to create a time-based UUID. Alexis says that he said the term UUID for mount is used as file system ID, but in general it's just universally unique identifier. Okay, okay. I still need to process this with some practice. Dash capital V for verbose mode prints much more information during operation than usual, useful for debugging. Let's put that instead of quiet. The hell? This is supposed to be verbose. What if I remove the verbosity? Now I get much more output. Is this trolling me? Let's put it here. This is not working as expected. Let's remove this part. Let's change it. Is this doing anything? The -v is behaving oddly. Mightiest, hello back to you, and welcome in. But here it says verbose mode, not the version. Ah, so the small caps. Okay. Small caps, yes. I'm gonna trust it that this is more verbose than the usual. I don't want to compare it right now, but apparently they either changed it in the utility or the PDF has a typo here. Creating an XFS file system. XFS is a high-performance file system originally developed by Silicon Graphics in 1993 for its IRIX operating system. Due to its performance and reliability features, it is commonly used for servers and other environments that require high or guaranteed file system bandwidth. Tools for managing XFS file system are part of the XFS progs package. So let's install it. apt install XFS progs. This package may need to be installed manually as it is not included by default in some Linux distributions. Others, like Red Hat Enterprise Linux, use XFS as the default file system, so obviously it will have these utilities bundled, right? XFS file systems are divided into at least two parts. A log section where a log of all file system operations, commonly called journal, are maintained, and the data section. The log section may be located inside the data section, the default behavior, or even on a separate disk altogether for better performance and reliability. The most basic command to create an XFS file system is mkfs.xfs target, where target is the partition you want the file system to be created in. For example, mkfs xfs dev sda 1. Did it make the partition already without asking me? Oh, that was the empty partition, right? So if we repeat it, now it says it appears to contain existing file system. Yeah. Okay. Now we have XFS on the SDA1. As in mkfs, mkfs.xfs supports a number of command line options. Here are some of the most common ones. sets the block size on the file system in bytes to the one specified in the value. The default is 4 kilobytes. The minimum is 512 bytes. The max is 64 kilobytes. -m for cyclic redundancy check value. Parameters starting with -m are metadata options. This one enables or disables the use of CRC32C checks to verify the integrity of all data on the disk. This enables better error detection and recovery from crashes related to hardware issues, so it is enabled by default. The performance impact of this check should be minimal, so normally there is no reason to disable it. -m sets the partition UUID to the one specified as value. Remember that UUIDs are 32 character numbers in hex base. -f to force the creation of file system. -l is the log device. This will put the log section of the file system on the specified device instead of inside the data section. What do they mean about device? Is it the partition or a block device? Or I guess that's the same. I meant the hard drive. This will set the size of the log section to the one specified in the value. The size can be specified in bytes, and suffixes like M or G can be used. For example, we'll limit the log section to 10 megabytes. -Q for quiet mode will not print the parameters of the file system being created. -L for the label. Most 12 characters. Wasn't it 16 for the ext4? -N will make print all of the parameters for the creation of the file system without actually creating it, but it's a capital N. Creating a FAT file system. Give me just a moment. I need to fill up my water cup. I'll be back in a sec. I think we should make these lessons a bit shorter in the future, or at least I should get myself an air conditioning or something. And the temperature outside is only 21 degrees. Imagine what it will be like when it's 30 outside and 100% of humidity. I'm gonna drop dead talking here. And wife made some kind of a cake. The FAT file system originated from MS-DOS and through the years has received many revisions, culminating on the FAT32 format released in 1996 with the Windows 95 OS R2. This is actually this exact version of Windows is actually my first PC. I haven't had a PC before this age. Just Amiga computer, Amiga 500. VFAT is an extension of the FAT16 format with support for long file names. Both file systems are handled by the same utility. mkfs.fat, mkfs.vfat is an alias to it. The FAT file system has important drawbacks which restrict it. That was a car. Which restricts its use on a large disk. FAT16, for example, supports volumes of at most 4 gigabytes and a maximum file size of 2 gigabytes. FAT32 ups the volume size to up to 2 petabytes and the max file size to 4 gigabytes. Because of this, FAT file systems are today more commonly used on small flash drives or memory cards up to 2 gigabytes in size. They're probably talking about FAT16. Because you most certainly can put FAT32 on a larger USB stick, and people do that by default. Or legacy devices and operating systems that do not support more advanced file systems. The most basic command for the creation of a FAT file system is mkfs.fat and then target, where target is the partition you want the file system to be created in. For example, mkfs.fat dev sdc1. So let's go ahead and do something like that. Let's do the Gdisk dev sdb. Yes, I know GPT is not present. We are now making it again. Partition number 1. Okay, delete partition 2, delete using 3. Okay, now let's create a new partition 1 from the beginning to the end, and the type will be 6. Was it 6 for the FAT? In GPT it's not just 6. Where is FAT32? I'm blind. Plan an eye. No FAT32 here. I'm still looking for FAT32. I guess I missed it. Never mind, let's write this. And let's edit with Fdisk and change the type to damn. Am I blind? Which one is supposed to be what? Maybe we are not supposed to do this on a GPT disk. MBR partition scheme. The type of the partition is MBR partitioning scheme. I thought that it would just do a conversion or something. A delete. Wait. Fdisk dev sda print disk label type GPT. And we are now in normal Fdisk, by the way. How do we convert back to MBR? Create an empty MBR. Oh. The device created a new MBR. Okay, the device contains GPT signature and it will be removed. Okay, that's fine. Partition, no, new partition. Primary one from beginning to the end. And now we want to change the type. L for the list. Which one was FAT32? FAT16? FAT16? FAT12? Ah, Windows 95. Okay, sorry. Let's go with 0B. 0B. Write it. Good. mkfs.fat32. Can I do that? I need more tools. apt install. What is the name of this package? DOS tools? Is it DOS tools? No. mkfs.fat. No such thing exists. exFAT progs. No, that's just exFAT. Oh, that's a stupid search. DOSFS tools. Okay, my mistake. DOSFS tools. Install apt file. Was it already installed? Yeah, it was. mkfs FAT. Just FAT. I can't choose the 32 or it will man mkfs.FAT is to create two different variants are supported. Two different variants of FAT are supported. Standard is FAT 12 and FAT 16 and FAT 32 as defined by Microsoft. La 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 la. So that's three formats, but okay. Normally, blah 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 blah. I want to tell it specifically that I want FAT 32. FAT size specifies the type of the file allocation tables. If nothing is specified, it will automatically select between 12, 16, and 32-bit, whatever fits better for the file system size. Press F. I suppose that's an honest joke, because it is F. Okay, let's do the F. mkfs.FAT-F32 and then dev sda1 and it's done. The Fdisk dev sda. It's recognizing it as VFAT, but the partition type is FAT32. But this is just the partition type. This one is irrelevant. The file system is recognized as VFAT. But okay. mkdir.FAT mount dev sdb1 no sda1 to FAT folder. Mount grep FAT. Yeah, type VFAT. Code page, stuff like that. No mention of the file system being 32-bit. Like other utilities, it supports a number of commands, checks the target device for bad blocks, file name, block count, will create the file specified in file name, and then create a file system inside it, effectively creating an empty disk image that can be later written to a device using a utility such as dd or mounted as loopback device. When using this option, the number of blocks in the file system must be specified after the device name. Okay, so if you want to make FAT images, select the size of the FAT. If not specified, it will be automatically. Volume label up to 11 characters. Verbose mode. Cannot be a bootable file system according to the manual page. This isn't as easy as you might think, and it will not be implemented. Okay. Creating an exFAT file system. exFAT is a file system created by Microsoft in 2006 that addresses one of the most important limitations of FAT32, file and disk size. On exFAT, the maximum file size is very large, and the maximum disk size is also very large. As it is well supported by all three major operating systems, Windows, Linux, and Mac, it is a good choice where interoperability is needed, like on large capacity flash drives, memory cards, and external disks. In fact, it is the default file system as defined by the Secure Digital Association for SDXC memory cards larger than 32 gigabytes. mkfs VFAT. Wait, is it mounted? Unmount FAT. mkfs VFAT. Dev SDA 1. Mount it. Grep. Dev SDA is type VFAT. Unlike previously, when it was also VFAT. Slightly confused by what these tools are doing, but apparently they keep making the same thing. What about exFAT? How do we do that? mkfs exFAT is here. Sorry. Unmount. I mixed it up. Unmount SD. No. FAT. Okay. mkfs exFAT dev SDA 1. Good. Format complete. Mount it again. Now it's exFAT. Okay. Now it's clear. So basically what this all comes down to is format everything as exFAT when you need FAT and ignore the previous types of file systems. The default utility for creating exFAT file systems is mkfs.exFAT, which is a link to mkexFAT. The most basic command is just placing it on a target. Blah blah blah. Contrary to the other utilities discussed in this lesson, mkfs exFAT has very few command line options. Sets the volume ID. This is a 32-bit hex number. If not defined, an ID based on the current time is set. -n sets the label up to 15 characters. -p sector specifies the first sector of the first partition on the disk, and this is optional, and the default is 0. I'm not sure if I understood this. Formatting a partition and adding it a parameter that specifies the first sector of the first partition on the disk. What if I'm formatting a second partition and adding this parameter? This is a bit confusing. It defines the number of physical sectors per cluster of allocation. This must be a power of 2. Getting to know the Btrfs file system. Give me a second for this. Hi, Nick. Okay. Btrfs file system, officially the B3 file system, pronounced as a Btrfs, or even Btrfs, is a file system that has been in development since 2007, specifically for Linux by the Oracle Corporation and other companies, including Fujitsu, Red Hat, Intel, and SUSE, among others. There are many features that make Btrfs file system attractive on modern systems, where massive amounts of storage are common. Among these are multiple device support, including striping, mirroring, and striping plus mirroring as in a RAID setup, transparent compression, SSD optimizations, incremental backups, snapshots, online defragmentation, offline checks, support for subvolumes with quotas, deduplication, and much more. As it is a copy on write file system, it is very resilient to crashes. And on top of that, a Btrfs file system is simple to use and well supported by many Linux distributions. And some of them, like SUSE, use it as the default file system. Note: on a traditional file system, when you want to overwrite part of a file, the new data is put directly over the old data that it is replacing. On a copy on write file system, the new data is written to a free space on the disk. Then the file's original metadata is updated to refer to the new data, and only then the old data is freed up, as it is no longer needed. This reduces the chances of data loss in case of a crash. as the old data is only discarded after the file system is absolutely sure that it is no longer needed and the new data is in place. Creating a Btrfs file system. The utility mkfs.btrfs is used to create a Btrfs file system. Using the command without any options creates a Btrfs file system. Unmount but mkfs btr. We don't have that. Debian doesn't have this as well by default. apt install Btrfs tools. Maybe with a dash. Nope. apt file. I forgot how it works. Action and the pattern. Btrfs progs. And what did I try to fetch? Tools. F me. All right. mkfs.bt. bt. Dev SDA 1. And that one is marked as Windows partition, but who cares? This one doesn't even give me an option to override unless doing this. Okay. Done. 10 gigs of Btrfs file system created. If you do not have the utility, look for Btrfs file system progs in your distribution. You can use the -L to set a label. It can have up to 256 characters except for new lines. So this is pretty long. New disk, fine. Enclose the label in quotes if it contains spaces. Okay. Note this peculiar thing about Btrfs file system. You can pass multiple devices to the command. Passing more than one device will span the file system over all devices, which is similar to a RAID or LVM setup. To specify how metadata will be distributed in the disk array, use the -m parameter. I'm just thinking about how to check disk. ls blk. 1 GB partition, 2 GB partition, 3 GB partition. There we go. Right, yes. Did not write, right. US okay, has been altered. Quit. Okay, SDB now has 3 partitions of different sizes. mkfs dot btrfs dev sdb1 dev sdb2 dev sdb 3 and dev sda1. Let's see if this works. Press F to continue. Okay, so what did we get? Performing full device trim, good. Several default settings have changed in the version. RAID 1 was chosen. Really? How? How did it choose RAID 1 with different partition sizes? UUID. How do I mount the UUID? I forgot. Man mount. Mount device mount point. No. File system type options. Can I just do the mount and the UUID, or do I have to tell it that this is UUID? We'll find out soon enough. Let's mount it to FAT. Can't look up block device. Okay. A parameter is missing. So this or this UUID or part UUID. Let's just do the UUID. I don't usually do that like this. Now it worked. Mount grep Btrfs. Something is off here. How big it is. It's 16 point something gigabytes. I told it to make a file system on all of these. So it's 3, 5, 6, and 10 more. So that would be like 16 gigs. So it kind of did. So it is striping, but the formatting tool said that it made RAID 1. which is odd because RAID 1 is usually mirror and RAID 0 is supposed to be striping. Man mkfs.btrfs RAID. On multiple devices, the default was RAID 0 until version 5.7, while it is single version 5.8. You can still select RAID 0 manually, but it's not suitable as default. So what is the default? What does single mean here? RAID. On multiple devices, the default is RAID 1. But what is RAID 1 from the Btrfs system perspective? Usually RAID 1 means mirroring. RAID stripe 3. Let's search for mirror. That's for metadata. RAID 1, redundancy copies. 2, space utilization 50%, minimum devices 2. So RAID 1 is mirror. But we didn't get... What did we even get? How do we find out the details about... Let me do something stupid. Oh, Btrfs convert to make file system from ext3. That's interesting. But I suspect this makes sense because ext3 may have been a default file system when this one was invented. RAID 1 for metadata for data which you see in DF. It's single. Something is missing. I have a hole in the knowledge. What is... When I see dev sdb1, I would think that literally this partition is mounted here and the partition is 16 gigs big. However, when I go here, I can see that it's not 16 gigs. So metadata is mirrored, but data is not. Okay, but how is it... Why is it shown like this? Why doesn't df tell me what's really going on, because this is misleading. If someone else did this and I stumble upon this computer that has SDB1 that's a lot larger than it actually is, I would be confused. How it is supposed to know? How is DF supposed to know? If it's a file system, Btrfs, it should report it somewhere. No? I mean, how do you deal with this? With Btrfs tools, I suppose. You need tools, yeah, okay. What is this doing? Man Btrfs. A toolbox for managing the file system. Okay, let me... Can you list my file systems, for example? Check device, manage devices managed by Btrfs system. Add, delete, scan. Btrfs device. Btrfs device. No such thing. Can we scan? What did I do? Unknown token. Okay, I'm stupid. Btrfs device scan. Will this do what I want? Okay, this needs a little bit more learning, which we are going to Btrfs file system df, like that. Show space usage information for a mount point. Not the same df, but okay, it is something. Metadata, RAID 1, data single, system RAID 1, global reserve. Okay. Device size 16 gigs. Half a gig went away. Okay. Just a little bit of practice. But I would still prefer if the DF authors could find a way to query this and show it in a different way. Just to give me a hint, like they do with LVM. Do it here. Tell me something different, and not just SDB1. It's a little bit misleading when you don't know what it is. Of course, when you see that this is a mkfs being a butter file system, then you're going to stop using DF and switch to other tools. But still a bit confusing on the first look. It would need special what? Since the kernel syscall they are using doesn't provide full information. So, I mean, I don't expect from DF to implement any kind of miracles, or maybe if the kernel would provide just a tiny bit richer information, that would be enough for. I don't know. I still think this is wrong. This shouldn't be like this. Maybe Btrfs system is not used enough in Linux for anyone to care about DF. D single, M single, and two devices. File systems spanning multiple partitions, such as above, might look advantageous as at first, but are not a good idea from a data safety standpoint, as a failure on a single disk or the array means certain data loss. The risk gets bigger the more disks you use, as you also have more possible points of failure. Managing subvolumes. Subvolumes are like file systems inside file systems. Think of them as a directory which can be mounted as a separate file system. Subvolumes make organization and system administration easier, as each one of them can have separate quotas or snapshot rules. Actually, one other advantage that a normal user would see in the subvolumes is the fact that all of the partitions, let's say you have a root partition and a home partition, both of them can use your entire hard drive. So as you fill up one, the other one will fill up as well. Alexei says, for example, RAIDs, there is a single block device, devmd0, but Btrfs system doesn't work like that, and old kernel interfaces don't know how to represent it. Yeah, correctly. So MD0 would be precisely what I would love to see. I mean, it doesn't have to be called MD, if that stands for the Linux fake RAID, but any other set of letters. It would be nice if someone would have any reason to implement it. Not for me, but subvolumes are not partitions. A partition allocates a fixed space on a drive. This can lead to problems further down the line, like one partition running out of space when another one has plenty of space left. Not so with subvolumes, as they share the free space from their root file system and grow as needed. Suppose you have a Btrfs system mounted on monitored disk and you wish to create a subvolume inside to store your backups. Let's do that. Monitored disk. Well, we have it at mkfs, but it is what it is. Btrfs subvolume create mkfs backup bkp create subvolume ls FAT. Okay. A directory. Let's create another one. Next, we list the contents of the disk file system. You will see that we have a new directory named after our subvolume. Okay. Subvolumes can also be accessed like any other directory. We can check that the subvolume is active with the command. Actually, let's check it with df first and then see the difference. Okay, so am I blind? Was it supposed to be mounted immediately? What did I skip here? Subvolume create. Check ls block. Nothing really here. Subvolume show, but I guess it's not mounted just yet. Maybe I misunderstood something. We should mount it first. Okay. I'm not sure if I know without checking the manual, but it should. Yeah, I don't know how to mount it without checking the manual. You can mount the subvolume by passing the t Btrfs system -o subvolume equals name parameter. Okay, that's it. Obviously. Mount -t Btrfs -o subvolume equals bkp dev sdb Is it the same for me and them? I also have the SDB1 just as they do. That was an accident. SDB1. We need a folder for that. We will mount it as SDB1 just for fun. This one will show nothing new because there is nothing new here, but mount will. Okay, so we have a Btrfs system as a subvolume / bkp from the SDB1 file system, which is spanning across 3 partitions on one disk and 1 more partition on another disk. How many times we spent figuring out how to do stuff just to read about it just below later. But I kind of like it. I mean, I'm not even thinking about it, how my head works when I'm doing this. I start thinking about how I would do it, and either I try to do it, or in this case, I completely forgot how the mount command works for the subvolumes. I never really think about the PDF giving me an answer because I just simply want to feel how, hands-on approach first, then reading from the paper. Maybe a bit slower. I will remember a bit more easier this way, because just reading about it, less of an experience, I suppose. But yeah, it is funny. It is funny. Let's mount the other one as well. Grep. What was the name? This one will be SDB2. What was the name of the other one? How did they call it? Another. I call it another. Okay, that's really me. That's really me. Mount. Grep Btrfs. Okay, so now, actually DF is what I wanted. DF is what I really wanted. Here you can see that dev SDB1 is mounted once here, and then dev SDB1 is mounted again on the other folder, and the same block device is once again mounted here, and each and every one of them has equal size, equally used, and equally available, and in the percentage, of course, they are equal. So this part I actually don't find confusing anymore, simply because I know that I did this, but ls block should group them, but they're not mounted. I mean, they're not block. Wasn't expecting this. Wasn't expecting this, but this is even more confusing because this partition is 1 gigabyte. So if I didn't make the RAID, this would be fine. This would be perfectly fine. But simply, please tell me that this isn't confusing to you. If you disregard the fact that you are aware of how I did this. Seriously. Okay, I actually spilled my water when I was going to the kitchen, and now I almost killed the plate. If you would see this and this, tell me it's not confusing at first glance. Well, there is 11 viewers on YouTube, and I don't know how maybe one other on Twitch. You tell me if this is not, does this not feel a bit confusing here? Like 3 mount points mounted on a 1 gigabyte partition, which is 16 gigabytes big. I love doing this. I love doing this. Linux is awesome. Alexis says you have a single file system spawned across multiple devices and mounted at multiple mount points. Not confusing at all. Another cool thing, if you go to, I guess, touch minute but another file, minute another file, okay. Now ls minute sdb2, and there's our file. Okay, this is not so funny. This is easy, but if you don't analyze what is truly going on here, this part here could be a little bit trippy. Working with the snapshots. Snapshots are just like subvolumes, but pre-populated with the contents from the volume from which the snapshot was taken. Yeah, and renaming a subvolume is as easy as renaming a folder, yeah. Snapshots are just like subvolumes, but pre-populated with the contents from the volume from which the snapshot was taken. When created, a snapshot and the original volume have the exactly same content, but from that point in time, they will diverge in 2 different directions. Changes made to the original volume, like files added, renamed, or deleted, will not be reflected on the snapshot and vice versa. Keep in mind that a snapshot does not duplicate the files and initially takes almost no disk space. It simply duplicates the file system tree while pointing to the original data. I don't believe that this needs extra explanation, but just in case anyone is interested in a little bit more verbose explanation, you know, when you have a file on the file system, but how do you know that there is a file? You need to have a file system tree, which tells where the file is. If you remove the file system tree, then the files are gone, right? I'm sure that some of you have sometimes in your life accidentally deleted a partition and you have been crying about it, but you didn't do a full format. You have just did a quick format of the partition. What quick format does is basically just tells what is it on the beginning? It just tells the disk that this is now a new partition without any files in there, but files are still there. So that's why all of those utilities that can recover files from a formatted file system can recover your files, because files are not really deleted. They're still on there. This is significant to explain the snapshots, because the way snapshots work and why they don't take up any space is because you have a file system tree which says that on our hard drive we have this file, and this file, and their names are called 1, 2, and 3. And when you make a file snapshot, then the only thing that you duplicate is this file system tree, and this file system tree kind of points to the existing files, and it takes almost no space, like really tiny space. And it is designed in a way with these tools. When you enter the snapshot folder, it looks like you have a double of everything, but in reality it's only taking up files 1 and file 2 and file 3 are taking up their original space on the hard drive. It just has sort of 2 pointers to those files. And when you, for example, delete the file 1, then the original, like production file system tree, will be updated, and it will no longer count file 1 as existing because you have deleted it. But at the same time, the second file system, that is your snapshot, still is pointing to this file, and basically it will tell the whole file system not to delete the actual file 1 from the surface of your hard drive. It will remain there because the snapshot needs that file to stay there. So that's basically how it works. If you want to recover some file from a snapshot, you can just enter the folder of the snapshot, pick your file, put it out, and once again it will I know the word in Croatian but not in English. It will update the original production file system tree and tell it that we have now copied a new file and pulled it from somewhere, because that's what we did, right? But when you make a snapshot, it doesn't take any space. The only time when snapshot is taking space, actual space on your hard drive, is when your real file system, production file system, and snapshot start to diverge a lot. The more you change on the production file system, the more space your snapshot takes. So if you make frequent snapshots and you keep only one snapshot, for example, this is what Arch people, a lot of them do. It's a fairly common thing to do among the Arch community, is before you update your operating system, you make a snapshot. When you do that, it takes like a half a second to do it, and it doesn't take any space. And then you use your computer until the next time you want to update your system. And when you want to update your system, you delete the old snapshot, you make a new one, and once again, your snapshot is taking no space whatsoever. So you can once again update your computer in peace. That you will have at least the ability to dig up the stuff that have been changed. It's not perfect, but it helps. So if you make a lot of snapshots, then of course they will take up some space, but that depends on how much your production file system tree has been changed from the snapshot. The command to create a snapshot is the same. This is not, by the way, the Btrfs file system only. All other file systems that do snapshots work in the same way. The command to create a snapshot is the same used to create a subvolume. Just add the snapshot parameter after the Btrfs file system volume. The command below will create a snapshot of the Btrfs file system mounted in a mkfs in my case, in Gdisk snap. What did I just read? The command below will create a snapshot of the Btrfs file system mounted here in the snapshot destination. Okay. Btrfs sub volume. Something is missing here, but okay. Snapshot mkt. I want. Can I do another? Oh no, it's not another, but it's called SDB1, was it? Check. SDB1. Okay, I want to snapshot only this one. SDB1, and if I don't tell it where to put the snapshot, I think it will put it into the root folder of that file system, and it will be called .snapshot or something like that. One given. Okay, so I guess that's not how it works. What is the second parameter here? Disk snap. That's the snapshot folder, I would say. SDB1 snap. Create a snapshot. Okay, that was SDB1, right? So it has a snap folder, and inside the snap folder there is nothing, which is good. Now let's touch SDB1 snap. Okay, file 1. Let's make another snapshot. Okay. Now let's make another file, file 2. Good. And now if you go to SDB1, you will see that we have file 1 and file 2. And if we go to the snap folder, what would you expect in a snap folder? I would expect 2 snapshots. One. Actually, I think I have overwritten the first snapshot with the one that's called the same. So I only have one snapshot, but inside the snapshot there should only be file 1. SDB1 file 1. Yeah, but it also snapshotted the snap folder. That's kind of inconvenient. we should tell it not to snapshot the snapshot folder, because that's going to be a problem. But also, we could make a snapshot on a different path that is better suited. Let's say rb-rf sdb1. Let's remove the snap folder and let's make another snapshot, but put the snapshot on mount pat snap, and let's call it create a snapshot. Yeah, we're done. What if I do it again? Let me just see what happened here. So SDB1 has file 1 and 2, but the snapshot went into the FAT folder and into the snap folder. And here we have file 1 and 2. But for some reason, we also have SDB1 with file 1 and file 2. Oh, because I have... This is a bit weird. Why did it create a subfolder SDB1 for me? What did I do wrong? What if I... Who is typing me messages? Element is so confusing. Ah, okay, I know who is typing messages. Actually, let me just drag it away. Man Btrfs. Okay. Snapshot. For example, it is possible to run sub snaps instead of subvolume snapshot, but Btrfs system S is not allowed because file S may be interpreted by quote. And that's what's bothering me. Subvolume snapshot. So it is subvolume snapshot. That's going to require a little bit more research into how to make... I mean, I can ask ChatGPT and stuff like that to get a quick answer, but I don't want to do that. Let's just go ahead and finish the lesson. Now imagine you have the following content in mount disk. So these are some files. These are some files. Notice the snap directory containing the snapshot. Now let us remove some files and check the directory contents. Directory contents, okay. However, if you check I'm getting messages. However, if you check inside the snap directory, the files you deleted are still there and can be restored if needed. Yes. It is also possible to create read-only snapshots. They work exactly like writable snapshots, with the difference that the contents of the snapshot cannot be changed. They are frozen in time just add the R parameter when creating the snapshot. Okay, a few words on compression. Btrfs supports transparent file compression with 3 different algorithms available to the user. This is done automatically on a per file basis as long as the file system is mounted with the -O compress option. The algorithms are smart enough to detect incompressible files and will not try to compress them, saving system resources. So on a single directory, you may have compressed and uncompressed files together. The default compression algorithm is zlib, but LZO, the faster and worse compression ratio, or zstd, faster than zlib, are available. With multiple compression levels, see the corresponding objective on mount options. It's starting to be tiring. Yeah, I agree. I agree. Let's see how much more do we have. A lot. A lot. A shit ton. Yeah, we are going to end it here, right? Good on you that you asked this question. This is where we stopped. 12 viewers on YouTube. Sorry to disappoint with the break here, but we did. We were at this for how long? 4.5 hours. So roughly 4 hours if we cut out the introduction. Yeah, that's a lot. They should have made this like a 2-part lesson for, I don't know, it's long. It's long. Every single one of you who have been on the stream today and still is, because I can see that there is quite a lot of you watching right now on YouTube and Twitch. Thank you very much for joining. We are going to continue this next Sunday at the same time. I'm going to announce it on my live tab of my channel, so you can go ahead tomorrow on that one and press something like notify me, but roughly it will be in 1 week minus 5 hours from now. So once again, thank you very much for watching. If anyone is even here, there is 12 people watching, but nobody dares to type anything in chat. Let me show it to you on here. Here on the matrix room, you can see what it looked like over the time. I think this means that 146 people have joined, because if you join only once and stay until the end, I think it counts that as one view. If you join only for a minute, it also counts as one view. So I think this means that 146 people have joined this stream for various amount of time, right? But right now there is 13 people here. Okay, part 2 next Sunday. Thank you very much for joining, and see you probably tomorrow in another random video.